All right, so we have a system of equations here today to solve. I've got two equations. This is the first one. This is the second one. And the objective is to figure out an x and a y combination that will simultaneously balance both of these equations. Generally, how we do that is we take some sort of information about one of the equations and substitute it into the other. So we could be substituting information about the second equation into the first, or first into the second. And there's all kinds of ways that that can be done. So I'll take you through the first method that I did, which was a little bit shorter, and then I'll take you through the second method, which took a little bit longer to do. So the first method involved me taking the second equation, working with it, and then plugging an expression into the first equation. So let's do a little bit of surgery on the second equation. Notice that if I was to take the natural log of both sides in the second equation, then I could use the power law. It's a very basic log law to lower those lns to the ground. So that's going to give me the ln of x times the ln of 3 on the left-hand side. And on the right-hand side, that's going to give me the ln of y times the ln of 2. Okay, well, if I just rearrange the factors to write like this, the ln of x over the ln of y, and set that equal to the ln of 2 over the ln of 3, then your brain is going to make a deduction here. It's going to tell you that at least for the second equation, one of the solutions is 2, 3, right? So a solution is 2, 3 for the second equation. So if this also was a solution for the first equation, then we would have our answer. But upon inspection, if I put a 2 where the x is and a 3 where the y is, I know that's not going to balance it. First off, I'm going to get a 4 here and a 9 here in the bases. And 4 is smaller than 9, and ln 2 is smaller than ln 3, so I know that's not going to be a solution to the first equation. Okay, so what can I do from here? Well, I know that if I have a number and I multiply it by 1, it doesn't change the value of the number. So there are many ways to multiply by 1. One is to multiply the top and the bottom by some consistent value. Let's just call it a. So a could be 2 or 10 or what have you. And that opens up another set of possibilities, because now what I could do is use that same power rule and bring that up as an exponent. So I could, if I wanted to, write the right-hand side here as the ln of 2 to the a over the ln of 3 to the a. And now this opens up further answers, at least to the second equation. This also tells us that any power of 2 that sits in the x spot and any power of 3 in the y spot is a solution. So this tells me that 2 to the a, 3 to the a is sort of a general solution for the second equation. Well, this opens up some opportunities, because now I could take these two expressions and plug them into the first and see if I could figure out what a is. So let's try that. So let's come to the first equation now. Now that we have some sort of genetic information about the second, plug that into the first. So if I do that, I'm going to put the 2 to the a where the x is, and that's going to give me 2 times 2 to the a, all to the ln 2. And that's equal to, where I see the y, I'm going to put a 3 to the a, and that's going to give me 3 times 3 to the a, all to the ln of 3. Okay, well that actually looks pretty manageable, because notice I can combine inside the brackets using a basic exponent rule. That's just going to be 2 to the a plus 1, all to the ln of 2. And on the right-hand side, that's just going to be 3 to the a plus 1, all to the ln of 3. I can get a lot of use out of this sort of power rule. If I take the natural log of both sides, watch what happens. So if I take the ln and the ln, I can take these exponents and write them as coefficients. So I'm using that rule a lot. Okay, So what does that give me? Well, ln 2 lands down as a coefficient, so the ln of 2 multiplied by the ln of 2 to the a plus 1. And what about the right-hand side? So the ln 3 comes down front, and that's going to be equal to the ln of 3 to the a plus 1. We'll take a look here. Look, a plus 1 is an exponent on this power that's being lned, which means that that also can be brought down front as a coefficient on both sides. So what does that give me? Well, that gives me a plus 1 on the left-hand side times the ln of 2 times the ln of 2, which is simply the ln of 2 all squared. On the right-hand side, same thing, a plus 1 times the ln of 3 all squared. Well, this is kind of nice because look, I could just expand the ln 2 squared through like any normal coefficient, same as the right-hand side. So what's that going to give me? Well, that's going to give me ln 2 squared times a, ln 2 squared times a is that, plus ln 2 all squared equals ln 3 all squared times a plus ln 3 all squared. And what I could do now is just sort of combine like terms. So bring all my variable parts to the left-hand side and all my number parts to the right. So if I bring this over to the other side, that gives me the ln of 2 all squared times a minus the ln 3 all squared times a. There's my equals. The ln 3 squared stays on the right-hand side. So the ln 3 all squared minus the ln 2 all squared. Okay, this is looking pretty good because look, on the left-hand side, I could factor out the a. So that's going to give me ln 2 all squared minus ln 3 all squared equals just the right-hand side, the ln of 3 squared minus the ln of 2 squared. And then that's just a coefficient on a, so I could divide it out on both sides, which means that a is equal to, well, the right-hand side, the ln of 3 squared minus the ln of 2 squared all over this coefficient, which is going to be the ln of 2 all squared minus the ln of 3 all squared. Well, I think we cracked it because take a look here. I mean, if I told you 5 minus 3 is being divided by 3 minus 5 and said bedmass it to give me an answer, you would tell me the answer is -1. That's just a property of opposites, right? These are the same numbers, but just in opposite places with a minus in the middle. So a turns out to be -1. This is good news because look, that's what we were trying to figure out. So it gives us the exponent on these powers for which we get an xy combination that balances both equations simultaneously. So the solution is going to be, in this case, 2 to the -1, comma 3 to the -1, or you could write it as 1/2, comma 1 over 3. All right, now let's take a look at the second method, which was sort of the same idea, taking the second equation and putting it into the first, but in a slightly different way. So the way I did it, this method, was I did some surgery on the first equation first. So I essentially started by taking the natural log of both sides, which ended up giving me a ln 2 multiplied by the ln of 2x. These are all being timesed. And on the right-hand side, the ln of 3 multiplied by the ln of 3y. And so what I did was I worked through to get ln y isolated and then plugged the second equation in. Okay, so let's show how I did that. So most of the work starts here. So I'm going to just rewrite the left-hand side as is. And over here, I used the product law. So that's going to be the ln of 3 times the ln of 3 plus the ln of y. Just a basic log rule. So I stopped there, and then I went to the first equation, rather to the second equation. So looking at the second equation, this here has to do with the first equation. Again, I took the natural log of both sides, so ln and ln, and that allowed me to drop these down, much like I did in the first method. So when I do that, I end up getting the ln of x multiplied by the ln of 3 equal to the ln of y times the ln of 2. And then essentially, I'm just going to isolate ln y here. And I'm going to plug it into here. Do you see? So I'm essentially taking the second equation and plugging it into the first. Okay, well, if I want to isolate ln y is going to be equal to the ln of x times the ln of 3 divided by the ln of 2. So I take this expression right here, which I'll put a little red box around, and plug it into this expression right here. Okay, so let me do that over here. So I'm going to pick up from here. So I've got the ln of 2 times, here I'm going to do a bit of expanding. So I'm going to call that ln 2 plus ln x, just using the product law. Over here, I'm just going to, because I'm going to run out of space, I'm going to say equals the ln of 3 multiplied by the ln of 3 plus ln y, which is this. Now there's the substitution. So I've got the ln of x times the ln of 3 over the ln of 2. Okay, what I'm going to do now is simply multiply the ln 3 through on the right-hand side. So my left-hand side I'm going to leave. So the left-hand side, I'm going to leave where it is. That's equal to the ln of 3 squared plus ln of x times ln 3 squared as well, all over the ln of 2. And at this stage, what I'm going to do is move all of my variable parts to one side and my number parts to the other. So here, if I was to expand that through, I'm going to get a ln 2 times ln x, which is going to sit on the left-hand side. So ln 2 times the ln of x. This term here is going to come over and meet with it. So minus ln x times ln 3 squared over ln 2. And then on the right-hand side, I'll just say equals for the right-hand side here, write the right-hand side information. I already have the ln 3 squared. And what's going to join it is ln 2 times ln 2 takeaway. Or a ln squared, ln 2 squared. Okay, well, now look, I could pull out an x squared, a ln x on this side. So I'm going to take a ln x out, and that's going to leave a ln 2 minus ln 3 squared over ln 2. Watch what I do. I'm going to expand that over and just call that squared. So I'm adding those together. Equals the right-hand side, just because I'm running out of space. Now watch what I can do. I can isolate ln x by multiplying both sides by ln 2 over this, basically the reciprocal of this. So that gives me the ln of x equals, well, there's my right-hand side, the ln of 3 squared minus ln 2 squared over the reciprocal of this, which is going to be the ln of 2 over ln 2 squared minus ln 3 squared. And what do you notice? Well, these are also those opposites with minuses in the middle. So that becomes negative 1. So that tells us that the ln of x is equal to the negative ln 2. Well, we can use the power rule again. That's going to be equal to the ln of 2 to the negative 1. Well, what's our deduction? Our deduction is that x is equal to 2 to the negative 1, or 1 over 2, which is the same x-coordinate we got when we used the other method. Of course, now what we'd have to do is find the y-coordinate by plugging that into either of the original equations. I leave that for you to try. But those are two ways, essentially, to solve this, using a substitution, using your log laws, and lots of inhales and exhales. All right, if you liked the video, please slap a like on it. Don't forget to subscribe, and I'll see you back here in the next video.